let me have your attention. So we're doing motors, and this lab, luckily we are taking apart a motor and putting it back together, so you can get a feel of how does it function, what pump can go with it. We're not going to go into very much detail. Most of the motor power function comes from the design stage. It's about design, so there's not much for you to do, but there are some switches you might have to check. They might break at some point, it might be obstructed, you might have to change the bearing. So we took this part of the motor apart. We looked if there's a capacitor. We did check the winding, look at it visually, is it darkened, is it burnt, look if there's any obstructions, look at the rotor, make sure it's moving freely, and so on. So this is basically what you will do with the electric motor. We have many types of AC motors. Probably if you did your paper, you had to deal with some kind of a motor. If you did a blender, if you did a fan, an AC, probably there is some kind of a motor involved in that device. There are different needs depending, again, on the speed, size, rotation, function, also location. Is it going to be indoors or outdoors? Is it going to be sealed or open? These motors have venting holes. This one doesn't, some of them do. Some of them need vent because they need to be cool while they rotate, otherwise it will overheat. So they have different jobs depending on what you need to do. So if you have something to do with compressors motors cannot be shaded pole. Why? What did we say about shaded pole motors?
No reverse.
Huh?
No reverse.
No reverse, I one thing. What else? Shaded pole. This is a shaded pole motor. We'll talk about it more, but it's very reliable. It's easy to construct, but it has low torque and doesn't have a lot of horsepower. So probably with motors, with compressor, you will need to have something with a lot of horsepower and a lot of starting power and torque. So shaded poles are good for small fan, operating small boiler, but not good enough for a pump and a water pump with a lot of elevation or a compressor. So the right motor for the right job at the right size also and the right alignment. Some motors are not to be placed in different orientation. If this motor was supposed to be laid horizontally, you'll have an issue if you put it vertically. So make sure that you have the right orientation. Also, you want to make sure you have the right clearance. How far is it from the base? How far is the squirrel cage from the face? If it's too stuck, it's going to grind, and so on. Generally, motor strings usually used for equipment that does a lot of torque. For example, we have, let's think of household appliances. What do you think of appliances that need a lot of torque?
Washing machine.
Washing machine.
Grinder.
Grinder. True.
Table saw.
Yeah.
Liquid blender. I know my dad's like a
No, I don't think it's a lot of torque. I think the bread machine.
Huh?
The bread machine.
Printer.
No, the bread machine, the machine that make bread.
Oh.
This has a lot of torque. It has to need
And the press.
What about the batter, the thing for cake?
yeah.
And
Just
the
look
huge
at the torque it
presser.
has to do.
Huge presser.
Which one?
The huge presser that the
The
presser.
juice?
No, the one that is like industrial pressers that like explodes. Like, for example, if I put that there, it'll explode it.
Those usually used to be hydraulics. Now they have motors. So
Yeah.
it's a press. So and some stuff requires speed. Like the blender actually requires speed more than torque. And if you go with like a blender, they have different speed and this one. But if you put a lot of heavy stuff, probably it will shut off. Tell it overheat switch to completely shut off. It does not have the torque. So torque would go power. So these are some of the most common ones. Again, we will talk about is the shaded pole split phase. This is one of the examples. Shaded pole does not have a start capacitor or running capacitor. I will also go on YouTube and show you some videos about different kind of motors. Why do you need to know? You actually don't know. You cannot know all the types of motors, but if you have to work with one, you want to know it has a capacitor or not, what kind of function it does. Have a general idea, but we're not going to build motors, or most likely we're not going to fix motors. If the motor is broken, usually you send it out or you replace it, even if it has a bearing. We do not fix bearings. But you have to know what is the right diagnosis for the motor, and if you were to install the new motor, you want to make sure that you put it correctly. Parallel split capacitor, it's also called ECM. So those have a capacitor in them, and the capacitor usually is a run capacitor. Capacitor start and capacitor runs. Two capacitors in them, usually they are large. The run capacitor only help the motor starts. That's the start capacitor, sorry. The run capacitors, it smooth out the running. It lower the voltage. So with bigger motors, usually if they are run capacitors, it will be having lower voltage than regular motors. Capacitor start, this is one with capacitor start. The motor has only a capacitor in it. Where else? Yep, yeah. So if you look here, that's a small motor. You compare it, it's running a pump, and it's running also the inducer fan. If we look here, the capacitor over here, and it's protected by a metallic case. So the first thing you'll check is the capacitor. You can check the microfarads, and you can check the wiring. And finally is the electronically commutated motors. Those are very common. They're very expensive too, because you can vary the speed, and it electronically changes the phase of the current inside the motor. So you can increase the speed, and sometimes you can also reverse the motor. You'll see them a lot for inducer fans in ACs, and you will also see them in mini splits and packaged air conditioners. So this is something that is for the homework. What is the motor speed? It's the flow reversal per second, which is what? What is the flow reversal per second? What's another word for this?
Frequency?
Frequency. So this is the frequency, just another word for it. Over times 120. What is 120?
Electronic
Voltage. That's the voltage. Huh?
120
Yeah.
voltage.
Here's the voltage. So the express 120 divided by the number of poles. Number of poles is something you have to find on the motor. Yeah. And this will give you the motor speed, which is the RPM question. Common motor speeds, as you say, 2 poles is going to be 3,450, and 4 poles 1,750.
So more poles, the slower the motor is.
Yeah. This RPM, but this has nothing to do with the torque. So we got 2 poles, 4 poles, 6 poles, and 8 poles. 900 RPM.
Well, isn't there a correlation with like the higher the amperage, the higher the torque, the
Yeah.
higher the RPM speed?
Not the torque. I know. There is, of course, a correlation. The more amperage you run through your motor, the faster it's going to be. So there's another correlation. But again, you have to gauge the amperage and how much you go through. That's why you have something called potentiometer. The potentiometer is something that you'll wind up. Let's go back a little bit. In the old radios, when you're trying to increase the volume or you tune in, what are you doing? You're basically changing there's a winding, there's a coil inside, and you're changing the distance of that coil and the intensity, which also increases the current and the magnetic field inside the coil.
So what if you need, I can understand with RPMs, there's the difference between 6-pole and 2-pole, but what would be a practical application versus a 6-pole versus a 2-pole?
This actually, you'll see this if you're doing a house fan. So the high speed is going to be 2 poles. So you activate different poles in the motor. So this is how you vary the speed. But if you put in high speed, it's going to be the number of poles that will be activated. Then you click it one more, and you activate more poles to get the lower speed. Until you finally go to the 8 poles, and you have very low speed. That's why usually you have certain amount of speeds, 1, 2, 3, 4, 5. To have something that varies in between, that's a different technology. They do actually change the amount of amperage going through the voltage. But that will be a little bit more expensive. Same thing with the dimmable light. To have a dimmer is very expensive because it does have the ability to change the amperage. So for the longest time, people try to find many ways to have reliable motors with different speeds because that will give you a lot of flexibility. And think about how long it took for us to find a motor that will, I was talking about the Tesla game, a motor that have a lot of torque and very small and can vary the speed and synchronize all four tires with ease and reliability. It took a long time. And the first electrical cars, they had only one motor, one electrical motor that's running all four tires. And there was issues with motors that could not be solved because again, it was new. Same thing with the internal combustion engine in the beginning. If you're ever familiar with the Model T, it was very slow to start with. It wasn't really fast. And there was a lot of issues with stability. So a lot of things has been added to the car to make it more stable at different speeds, especially when you turn. Okay, I'm gonna divert a little bit into when the car turn. Do you know that your car has a, what's it called? Differential? So the differential actually, when you turn, you know, one wheel requires more torque than the other. You notice that? So if you don't have a differential, what will happen? Your car will skid.
Yeah, sure, yeah.
That's why when you have four-wheel drive, you have more stability during snow, sand, or different speed, different tire. The car will go based on the torque for each wheel and balance that torque. That's what a Subaru does, or all-wheel drive cars do. All the wheels have the capability of turning, but you have a differential in every tire to measure mechanically with sensors what is the torque for each part. So again, advancement in motors came with this kind of mechanism and new technology. Some schematics for motors. Again, you don't have to go into depth with any of this. All you have to know is there's a main winding, secondary winding that runs with the capacitor here, and it will cut off once the motor reaches the required speed. Different components for the motor and pump, and if you take the time to think about the components, you will notice that you'll go through some issues when you try to put things that are rotating in a horizontal place. In terms of bearing, the weight of the shaft is going to be there, right? And if you notice the weight of the shaft, it's being exerted on the case in the beginning, but once it spins, the weight gets lighter. Same with the car. When you start from zero, it's a little bit heavy. It's a lot of effort. But on the highway, you really don't do much. You're barely even touching the pedal. So once you start the momentum, it will keep going. So same thing with bearing here. And if you look at small motors, they don't even have ball bearing. What do they have? They have what's called sleeve bearing, which means metal, touching metal with a film of oil in between. So the only time where you will have friction is when you start. Then the shaft will be balanced by centrifugal gravity under force, obviously spinning, and there will be no need for bearings. The other thing we will think about is when we have a pump, we have something called bushing. What bushing does is, since I have the shaft going through a casing, there must be some space where the water can come out, where the liquid can come out. So what the bushing does, it's basically pressed against the shaft continuously so to prevent the oil or water from coming out. Again, if you look at your internal combustion engine, the engine has oil in it, right? And also the piston is going up and down with oil. There's oil inside the walls, but the oil is not supposed to go into the combustion chamber. What happens if the oil goes into the combustion chamber?
Burn fire, or like it could ignite.
Smoke. You lose oil. So what's preventing the oil from going to the combustion chamber? Meanwhile, going up and down all the time.
What's that thing called again?
Bushing? Combustion, yeah, bushing. So if you look at the
Is it like an O-ring, kind of?
yeah. So we have our piston here. You have your crankshaft here, and this thing's going up and down. oil here, right?
Yeah.
This thing going up and down, but this area is completely dry by the time it comes down. Why? We have some kind of bushings, and we also have some O-rings. And those O-rings, this piece of metal, sideways, pushing against the wall of the cylinder, wiping down everything every time you go up and down. That's why every once in a while, probably after 200 or 300 miles, 1,000 miles, you have to change those rings, because imagine the amount of wear and tear that's going on the walls, especially if the oil is low quality. After a while, this wall will get a little bit grooves in it, and some molecules of oil will go through. Question.
So that's why it makes that sound when you have to get an oil change? You know what I mean?
No, probably
Like-
something else. But probably something is, there's some kind of roughness in the engine.
No, I know, but you know how like, you know, when you need an oil change, you
Yeah.
get the sound? You know what I'm talking about? I
No.
know, you have a Honda, so you must know what I'm talking about.
No.
Hondas burn a lot of oil.
Mine does it.
Okay, never mind.
Mine does it. I don't hear that specific sound. By the way, Honda goes by year by year. It depends. The point being, I'm trying to explain is the bushing here, is that what isolates the liquid part from the movement part. So probably you have some in here, and also you have something between the shaft here to prevent it from going. And again, it's a really easy thing to replace. It's just a ring. But what happens is, taking apart the engine is a big deal. And also you have to machine the cylinder itself. Because this, over time, it will have some grooves in it.
Oh, you gotta rebore it?
Yeah,
Tell me you can get more power out of this?
yeah.
Hell
So
yeah.
they have 3 or 6 saying we can make it bigger, and you have more bushing. And again, the bushing has a lot to do with the surface area. More area you have is going to be bigger, more square foot per pound.
Hell yeah,
Work
you can
on.
do that.
And that's what people do. For race cars, you have bigger.
Oh yeah,
engines.
you bore out.
And when
the-
they tell you the engine is 7.5 liter or 7 liter, 4 liter, what liters are we talking about?
Like NASCAR cars.
We're talking about the volume of the displacement, the
Yeah.
volume of the inside the cylinders. That's why when you buy one of those big SUVs with 7.5, it's big, cylinders going up and down, so it's the clearance of what? The piston.
Total, right?
Huh?
Total.
Total, all before, yeah.
Yeah, I know.
Some cars actually tried having isolation of number of cylinders. I know the BMW, the 850, it's 12 cylinders, but you can choose to make it 12, 8, or 4.
Okay.
So you can shut off
I know,
some of them. But that idea did not last long. I
my
don't really have
mom's
that at all.
Pilot, if it's cruising at a steady speed, it'll shut off on one of the banks and only run on 3 cylinders.
Hey, here you go. They made it.
I mean, I know a lot of Hondas do that.
Yeah. So that's a good idea to have, so I don't have to run 08 all the time. Because again, in the highway, if you, as I said, the friction is gone, you only need small energy. Why do I need all this 8 cylinders running at the same time? Probably you need it when you're going uphill, when you're accelerating, but in the highway, you don't need all this power going on. So that's another idea to save on gas. Okay, 2 types of motor, open motors and enclosed motor. And open motors have a housing, and like this one is open. You can take apart the motors and it's working outside. And enclosed motors, they're housed within some type of shell, like hermetic compressors. There are other motors, for example, the pump motors, they're housed with the pump. So you think the whole pump is just one thing, but actually it's 2 things, but they are completely enclosed. And you're not supposed to take them apart because you might ruin the bushing and you might have some kind of clearance and you start leaking some water. So they're completely sealed. Submerged stuff are always sealed. Your gas pump in your car is sealed. I hope so. I mean, it's in the gas, it's submerged. So submerged stuff are always sealed. Example of hermetic and open. Here's what I want to talk about is the dimensions. Those are very, very important because if you were to do a replacement, you need to have the right size of motor and clearances from other equipment. Usually you'll go through this as a problem. If you were to replace old equipment and you need to find a motor and you want to be the same size to fit in that space. The only problem you might face with small motors is if you are pushing too much into the shaft, or the shaft having too much load than it's supposed to. If you have to squeeze it in and tighten it, you might tilt the shaft. So let's look at it this way. If this is my motor, first of all, if this motor is designed to be placed horizontally, probably you should not put it vertically. Even though it will work, but you have changed the design. You should not do that. If I put a bigger pulley than I'm supposed to, and this motor is a little bit tilted, the force is acting on this part is more than on this part, so the tilt will cause the force to change, and eventually this will leak and vibrate. So you want to make sure you have this distance correctly. The distance between the connection and the shaft is very important. Otherwise, you might have some kind of vibration. If this is too small, you might have vibration between those two, and also it might cause some grinding. So listen to the sound, and also try to see the free movement. And again, some stuff when they're cold, they operate very well, but once they overheat it, and once they have a lot of pressure, things will change. Your car in the morning sounds different than when you first turn on than like 15 minutes later. It has more noises and different sounds. After 15 minutes, it will be smooth. So probably it's cold, the oil is cold, the belts are tense, especially in a day like this, so it's 25 degrees. Everything is probably cold. So it's important to do things like stabilize them, do measurement. For example, also they tell you never like floor the gas when the car is cold.
No.
Wait, what?
Never floor the gas
When the car is cold?
they are trying to heat it up. Probably you can count the time you will do that before something breaking the engine.
Yeah, because your oil isn't warm.
Everything is cold.
Yeah.
Things might break. If you just go there and explore the whole thing to try to warm up the car, you're actually killing your car. So things might explode.
I know,
Do you
right?
notice that it's easier to break things when they're cold?
Oh yeah.
So I'm killing my car is what you're telling me.
Well, I don't know if you're doing that, it's really bad.
Just like when you heat up a pipe and cool it real quick. you
Yes,
just hit it.
quenching. So, in some metallurgy ideas, they cool things with nitrogen. Liquid nitrogen gets like, you tap it and it breaks.
Yeah.
Yeah, so it's really intense. So think about it, this is an exaggeration, of course, using liquid nitrogen. But if your car is completely cold and you suddenly put it in full fledged,
Yeah, I know.
probably it will break the engine. Again, going back to the
Wear down
BMWs.
other parts of it too.
The BMW would not let you do that. They thought about that because they wanted to preserve their engine. And the car's under warranty, so the car will not even let you floor the gas with the car is.
What car one?
BMWs usually, in the 90s, they won't let you floor the car completely warm. Okay, so it's something they call engineering foolproofing. So prevent things from happening completely. Shaded pulse motor, very small starting and running torque. The current is induced into a shaded pole from the main winding. So we have, let's say, our normal poles. There is a shaded pole here on the side. This is normal, north and south. And let's say this is the current. I will take a branch, have it offset and have another south and north, just to push things offset so the motor will not stabilize and stop working. Reversing, if you want to reverse, you have to take apart the motor and reverse the entire structure. If you look here, this is a shaded pole. See, there is no winding, there's a wheel, there's a rotor, and it's just the way it is. So you might have to reverse the entire thing if possible, and sometimes you might not. But some of them have the ability to be reversed. They're usually single speed, that does not vary the speed. Troubleshooting is easy. Just look at the winding, look at the patterns, and make sure that nothing is frail and there is no burnt coils. That's basically what it. How do you check it? How would you burn this motor? The only thing you can think about is something gets stuck inside, overheated, the switch does not trip, and you burn some of the coils. And again, those are really easy fix. Somebody will come and they will see how they intertwine the coil back and forth. Somebody just go and put some coils through it and change the coil. A lot of when you buy a new alternator, they take the core from you. It gets sent out to shops and rebuilt because nothing in the alternator can be changed and fixed. They fix all the small components and you reuse it. So no starter application, very small torque, small application, and winding makes up the starter torque. That's why it's not a lot. And they do not reverse. This is the one problem. Huh? Yeah. Okay. Good. Got it?
No.
Capacitors. This is a capacitor. A lot of them made out of aluminum, some of them made out of plastic as casing. They try to make them thin so that they do not build pressure because they do hold a lot of charge. So these are the starting capacitors. They are filled with oil and electrolyte. So it's called electrolytic capacitor. And there are also oil-filled or running capacitors. Also, both the oil and electrolytic have chemicals inside that will hold the charge. The older one used to have wool-like material. So they were lightweight, but they again don't last as long and they do not hold as much charge as the oil filled with the electrolytic. So in troubleshooting, short capacitor life and malfunctioning. They usually change every couple of seasons. They're not that expensive, but again they go through a lot of cycling. Every time the motor goes on and off, you will discharge and charge the capacitor. Think of it as a battery, but does not have a current, only have a charge. Your battery have also a life cycle, right? How many cycles of charging you get out of a regular lithium battery? If it's a rechargeable battery.
100,000.
Huh?
100,000.
No.
Few hundred?
You wish. You wish. Okay, when you buy a new phone, the battery is great, right? The battery is champion. When you start to feel that the battery is really...
After 3 years.
Not really, I wish.
1 year, 3 years.
1 year. After 1 year, it starts like going down. So,
Battery,
It's 2
it's where
years
it plugs
already.
in.
Huh?
It's like where it plugs in, that's where the problem
not
is.
really. The battery actually life decline.
Yeah, but
Yeah,
if
I
battery's
shows
fine.
that.
you leave it over
Like
charged
this phone
overnight,
2 years old,
it's
it's
bad.
like brand new.
How much did you have did you charge how much you charge it? How often do you charge
Every
it?
other day.
That's why.
Every other day.
If you charge your phone 3 times a day, you're using the battery. The point being is, eventually, huh?
My maximum capacity is 78%.
So he charges
Doesn't
once
matter
every
if
2
you
days.
use it or not.
That's why his battery lasts 3 years. If you charge 3 times a day, probably the battery starts to wear off
And if
in
you
1
use
year.
a charger that's not like a
That's
from
true.
your phone's like
Yeah.
company, they're not made to use the same power, they're just made to charge
What?
like a.
Yeah. What do you check now? On the battery charger.
98% angry.
Yeah.
Battery died.
So now that you know electricity, what do you check when you want to match the chargers? Milliamperes. How many amps is it giving me, and what is the voltage? Make sure you match the voltage. Because you can charge with higher voltage and different amperage, but eventually you will ruin your battery. So think of the capacitor as a battery that also goes back and forth every time the motor comes in. So eventually, what happens in the bigger picture with the battery and the capacitor? It's called the return cycle. Every time you combine those two chemicals and decombine it when you get electricity, you get some byproducts from it. small percentage of byproduct. We don't completely have 100% transformation. It's just like when we burn fuel, we don't get all heat, we get some other stuff. So it's very small, and over time, at the end, you have no more left of the actual material, and they are completely combined, and you have a lot of byproduct. That's when the battery do not hold charge at all, and it's dead. Okay. Capacitors. Simple again, we went through this, and these are some of the common plastic capacitors. They do have something called a turbo capacitor, which has many outlets, so you can change and get whatever charges you need. What do you look in a capacitor? Two things.
Voltage and.
Voltage and
microfarads.
Microfarads. Split phase motors. They have two general classification. Resistance start, induction run motors, capacitor start, induction run motors. So they're both induction run motors. Some of them is resistance starts, and some of them are capacitor starts. If you are taking the refrigeration class and you're doing compressors, probably you saw a lot of what they call them, starter relays, resistance relays, chemical relays that are put outside the motor. Split phase usually are very strong. They have good high torque relatively to the shaded pole. Some of them have resistance start, which is kind of like a relay, and some of them have capacitor to kick in the rotation. Similar construction, different application. So we're splitting the phase again. It's not like the shaded pole, no. The pole is a small branch out of the main phase. This is a split phase to have different way to speed up the motor, and eventually you have to cut out the startup winding, otherwise the motor will keep adding up speed. So far, if you don't remember much of this, I want you to remember a few things. Capacitors, you need one for start, one for running. If they have capacitors, you need to check the capacitor first. Second, the motor needs, if you have a single phase motor, you need some kind of configuration or some kind of a need to kick it out of phase and have it start. And this could be either a shaded pole, it could be its own winding, and you have to take it out. Second thing I want you to remember is you don't want the motor to overheat. If you have some need to increase the speed, you want to shut it off at the right speed, otherwise the motor will overheat. And what else I want you to know is what components are in the motor. And actually when you do the lab, you will get more familiar with it and see it's not really that intimidating. Resistance start, induction run motors, starting and running winding makes sense. So this is how we start the motor. Some method beginning the rotation, a winding. Operation phases are split by making up starting winding. So we have again startup winding and running winding. Some of the problem you will face is bearing, winding is burned up. We already looked at that. And centrifugal switch. So what does the centrifugal switch look like? It's this thing in here. If you look at this switch, and you can see it, this kicks out when the motor starts to speed up to cut off the startup winding, because the startup winding is built inside the motor. So what I have very clear is the startup winding. That's why this motor is not working anymore. Okay. So I think I'll stop here.